Hi, welcome back to the stream. I feel like I'm welcoming all of you back when I'm the one who's gone, but, you know, anyway, it's nice to be back. I was going to put Tuco's nap up on the stream, but Tuco just came over here to join us. So I don't have a lot more time to stream today, but I wanted to at least spend like another hour or two digging into this HelloSense that Allison sent graciously to our P.O. box here. And this device, I was just thinking about it some more and thinking about how to describe it. Also, sorry if the mic is too hot. I was noticing just that from earlier that's probably just too close to my face. See if that's a little better. Yeah, so I don't know, some folks on the last stream were comparing this to the Juicero or the Juice Bro, and but it's sort of like the Juicero of like small IoT sensor appliances, basically. Oh, that's, oops. Well, we just plowed right through that obstacle. That's fine. We didn't need an obstacle detector or anything. This thing's a little hard to steer right now. There we go. Yeah, so on the previous stream, which was just earlier today, we dug into the HelloSense, took the bottom off, looked at all the circuit boards under the microscope. It is just ridiculously complicated for what it is. And this outer enclosure just got me thinking, like, this thing is their marketing. It's a rendering, basically, that they brought into the world through just sheer willpower and VC money. Like, on the last stream, we were looking at the video that they put out of the injection molding tooling, which I had been curious about, because, like, how do you even make something like that? It must require this huge multi-part mold. And yeah, they made a mold, and they put up a video of it, and it's a huge multi-part mold with some, like, really impressive moving parts, and it just looks extremely expensive and extremely hard to maintain, and just completely unnecessary. And it just got me thinking, like, this whole thing just feels like almost this extrapolation of Apple's design mentality into something which exists only to send a signal to, like, other startups and people who invest in those startups. It's very strange, because, like, they didn't succeed in making this product viable, but they did succeed in putting this image out there, and somebody got a portfolio piece out of it, or two for sure. So there are some designers out there that got to, you know, say, well, you know, I didn't make a product that survived in the long term, but I made this amazing design, and we proved that it's possible. But, like, to my mind, it seems like part of the reason why the success overall wasn't possible was probably because the you know, the individual pieces were just so far into the territory of just sort of proving that you can do something that's possible versus just actually doing something that makes sense. And so then this acts as this, like, kind of false goalpost for other startups and other VCs who can just point to it and say, look what they did, it's possible, without actually having to notice the reasons why it failed necessarily. At least, you know, maybe I hope they'd look closer at it, but yeah, it's just... And I mean, admittedly, you know, I part of the reason I think about this is, like, you know, I worked on a project kind of similar in the past. You know, maybe it wasn't this extreme. We were certainly designing something to be affordable rather than this, which seems to be pretty no expenses spared. But there's still this culture of making something that turns out not to be practical, but still gets held up as an example of something that's possible. Because so much of startup ambition is kind of driven by that gulf between what's possible and what's practical. So yeah, interesting product for sure. So on the last stream earlier today, we just kind of took it apart, looked at the boards, looked at the marketing copy. I still want to open the power adapter potentially, because it's got this really cute little power adapter. I haven't seen a 5-watt adapter in this form factor before, and it's not necessarily, like, it seems like a product from another company that they just rebranded, but it still might be interesting to open. It's maybe harder to get into, and I don't know if I have time to open this one up, given that it's probably going to require the Dremel. So that might have to wait for the future. But I did want to at least try to get the little Bluetooth pillow clip object. This is a lithium coin cell powered thing that communicates using either BLE or just Nordic's GFSK radio. I'm not really sure which. The hardware, it seems like it could be either. But this is just a sort of a remote sensor that attaches to your pillow and helps with data collection while you sleep, which is what this product does. And then I just wanted to, take whatever other time I have to look at the GitHub repo a bit, because another thing that makes this interesting is when the product, when the company went bankrupt or whatever, ceased to exist as a functioning entity, they did at least open source, in fact, not just their software, but actually the electronics, it looks like also. The schematics and the PCB layouts are in Git. So we could take a look at their GitHub and see what's going on in there. Ah, this cat is a constant distraction. So yeah, and part of why this product came my way is that even though this looks like basically the Juicero of sensor networks, they're also actually apparently pretty cheap to find on eBay now, because they're basically useless since the servers are no longer in operation. So it became one of those IoT products that just effectively is bricked when the service dies. So now you have these meticulously engineered art objects that don't really work for their original purpose. So yeah, it's a good question, like, well, what else could you do with it as this, like, strange, meticulous art object? It's, like, weird, like, thinking about this as, like, some designer's portfolio piece, or, like, some kind of art that takes place not in the context of the museum art world, but the VC-funded art world in San Francisco. Oh man, I could pet this fuzzboy all day. Yeah, so James is saying it's BLE compatible. So they're using a chip, the Nordic NRF51822, I think, which supports both BLE and like GFSK kind of lower level protocols. So it does seem like it's good to know that it supports BLE and talks to the phone. That doesn't necessarily prove that it would be using BLE to talk to the little pillow widget thing. It certainly could be, but like that by itself wouldn't be proof that that's how it speaks to that, because the radio could do multiple protocols on the base station side. Hey Took, you like to inspect the stickers? I'm gonna put the cover on some of that. Alright, and I was trying to get into this thing. There was an old video, like a few-year-old video, showing the cover just popping right off of this for battery replacement, but it seemed like that might not still be accurate, and I tried doing that. It certainly doesn't seem like it works. This seems very glued together, so let's see how much progress we can make, and maybe I can manually aim the camera a little bit. Oh, is that purring? Some of that was purring. Oh, I don't see the remote control. Oh, here it is. Here's the robot. Oops. That's the 3D printer. Hey, Took. You like these wrenches too? Yeah, these are great wrenches, but they're probably not great for your teeth, honey. Oh gosh, this cat. Okay, this is gonna be harder than I thought. You are a little vibrating fuzz tiger. Aw, You are so sweet. Was I just eating something that he finds tasty, or is he just being affectionate? I think he's being affectionate. He's usually like this. Aw, Took. You're really in the way sometimes. Oh yeah, you just want to play with this now. You gonna help me open this, Tuco? Oh, no, don't do any of that, Tuke. Don't be eating stuff. Let's find a storage solution for these parts. I should get a tiny anti-static bag for some of this. Hey, Tuco, don't eat stuff while I'm over here. Alright, let's hold the cat's attention while I'm on this side of the shop. Yeah. You're doing great, Tuco. Cool. Yeah, don't eat any of that. Let's put this in the bag. Let's put the overly complicated, expensive circuit boards in the bag. Oh, Tuco. No, honey. Oh, we found a cat toy in this package. That's what happened. Wow, Tuco. Yeah. You're doing a great job helping me open this, actually, now that I think about it. Can we get this in focus? Oh, Tuco, you're doing great. This thing rolls some distance. I wonder how many people who actually tried using this product had this problem with their cat. So I have to ask the Hello folks if they intended this to be a really good cat toy. I took. Ow. Tuco, I don't think this is working, but I'm willing to keep trying. Yeah, so unlike a Bolt, this cat toy has Bluetooth in it. It's good to know that he likes to play with things that are not exactly CR2032 shaped, but, you know, could contain a CR2032. I certainly don't want to train my cat to play with coin cell batteries, not that I would have any of those available. Someone on Twitch says they're gonna come back once the cat is gone. Wow, are you really that anti-cats? I'm sorry, that must be sad. Yeah, right. Tuco is going to open this the same way that the crows outside would. That's pretty good. So, just looking at this, it seems very glued. I haven't seen anything conductive so far, so I could go in with the metal spudger. Wow, if folks out there were hoping to get electronics with zero cat, they're not going to have a good time. Because I think we've got a non-zero amount of cat going on for the foreseeable future. Speaking of Bluetooth cat toys, there's also that, which he doesn't need to wear right now. He was just in the hallway earlier today and I hadn't taken this off yet. You done playing with this, Tuke? I still want to open it. Oh, thanks, boy. Yeah, I guess that's an interesting idea. Like, the tile does have a beeper as well as Bluetooth. It might have the parts to make kind of an interesting cat toy if you could put new firmware on it. Which seems pretty easy to do once you've actually opened it. Maybe I will put a little bit of isopropanol in here just to soften the adhesive if it's got adhesive. I scared to go away again. As far as I can tell, this is like a rubber thing glued to the back of a circuit board on this side. I think the isopropanol is helping. I think the battery's on the other side, if I'm reading this right. Hey, Duke, don't be messing with that. That's wire. It's not good for your mouth. Let's go over here. Heavy boy. Oh, I'm so glad I got this. So I used to have, well, I still have one of these magic arms with the like locking lever, which is really quick to lock, but it locks with a lot of force, and I've hurt my hand several times locking that lever and unlocking it. Whereas this one takes a little more time to do, but I find it way more ergonomic. Let's see where Tuco went. This is extremely glued. I mean, we could check the other side. So, like, the other thing is the video we saw had them opening it from the side with the hello logo, and that was where the battery was. I don't see the battery in this side. So, like, does the other side want to pop off in any sort of reasonable way, or is there a cap that we can get off? Because it seemed like over the battery side there was just a plastic cap from that video, but I'm assuming that was like a redesign ago. Like, how many times did they design this for their $10 million or whatever? Oh, is that it? I'm pulling, and something is moving. that's the battery holder. Yeah, let's just hulk the battery apart. That battery has solder tabs. I don't think I'm breaking it too badly, but that is definitely the battery side, and it is definitely not replaceable. Although I think I'm getting the gasket thing off. I think that little bit of isopropanol helped, actually. That's not a piezo, is it? No, it's a battery. It says lithium cell. It's like a fancy battery, though. That's probably why they didn't make it user replaceable, is they wanted to put a fancy battery in here. So that you make it disposable, but last a long time and expensive. Like, that seems like their target market or something. Not that their target market seemed to exist especially much, but... Oh, is that a flex circuit? Is this whole thing just like full of flex circuits? I think there's a flex circuit opposite the battery on this side. Right. Ugh. What are we doing here? I don't want to go in this side that much more without getting more of the adhesive off around the other sides of this. Oh yeah, actually maybe I can get the flex circuit off of the rubber here. Maybe that's the next step. There's a plastic piece that is actually glued. Oh, so this is why it was easy there. So I think the glue between the plastic piece and the battery was much weaker than the glue between the plastic piece and the rubber. And so I managed to like pull the battery off of this plastic mount. But the rubber is more strongly attached. This thing is terrible. Oh, I should not kick the camera. Let's try going on the other side a little bit, maybe. Well, now that I'm not worried about this side containing a battery, and I'm just worried about scratching the circuit board, maybe I'll be a little less gentle on this side. I'm also probably just going to start pulling pretty violently at the rubber. I've been trying not to, like, rip the rubber especially, but I might see how far I get with pliers or something along those lines. But yeah, at this point, I'm kind of worried about damaging the circuit board still. And definitely worried about damaging that flex next to the battery. What is that doing? What are my plier options? Oh, I've got a few good plier options here. Oh yeah. Well, James is asking about repurposing this. Yeah, my confidence that this is going to be usable after disassembly is a little low at this point. So I think like we could keep it in one piece and try to repurpose it, but I think I'm here to do a teardown, and so I think that's priority one. If we want to make like an IoT cat toy thing, I think there are a lot of ways we can do that. But right now, I want to kind of document what's going on here a little bit. So, can I show you what's going on in there? Not really. I'm not quite sure how much I can bend this without breaking something. It looks like the flex is really delicate and connects to the lithium battery, so I'm trying not to short anything out or break it. This is such a bad design. And then this side, circuit board is underneath there. Maybe we should be going servo AF here. watch out, Tuco. Hey, Fuzzbo. Oh, yeah, okay, cool. It looks like there might be a source of additional objects if these are actually useful for anything. Hey, Tuke, let's take you elsewhere. Why was that not tracking? I think it was in stop mode. Some of the wobble protections I put in are full of false positives and it keeps turning off tracking. Whatever, I can't debug that and tear this apart at the same time, I think. Okay, so this side doesn't have the battery. I'm a little less worried about soaking it in isopropanol. I'm hoping the protection's on the other side if there needs to be protection. I mean, this is a non-rechargeable lithium. So it doesn't seem like... I mean, I don't think I need to worry too much about the battery as long as I don't physically damage it, because I doubt it's got... I suspect the internal resistance is high enough that even if I shorted the battery entirely, it wouldn't be especially dangerous. But I'm not eager to damage the battery, which could be a little bad. Isopropanol and pliers. Seems to be the way in. And a lot of pulling and some patience. So yeah, so I guess a couple of folks in chat, back to the Kickstarter, did you actually try using the product for its intended purpose, and like, what was the experience like? I'm kind of curious. Okay, Servo AF is not doing us very many favors right now. Right, isopropanol and pliers is a pretty good way in. Oh yeah. Well, that's bad if it only quantifies as like sleep you take at night. And yeah, like sometimes like if you're taking a nap or if you're depressed, like sometimes it's really good to be able to get continuous tracking, and it's frustrating to have something so personal controlled by something that you don't actually have direct control over. So I don't know. Because it's like if you were tracking your sleep without an IoT device, well, what would you do? You'd probably have like something that collects data while you're asleep if you wanted that, and just like lets you view logs. You might have like a spreadsheet or a logbook or something. And these you'd all be able to customize if you wanted it to track something slightly different, like especially a spreadsheet, right? It's like, I feel like the promise of computers in the 90s was like, you can use a spreadsheet to like track everything just the way you want. And the promise now is like, give us all your data and then maybe our shitty algorithm will figure out how to tell you something useful. It's like not really a good promise at all. It just feels like kind of this excuse to get data without like having to actually return return anything of value. Yeah, and I don't know about sleep trackers in general. Like, I haven't tried any personally, but I've had close friends who have tried them and haven't really. Yeah, I don't know of anybody I've tried who's had like a really good experience with them. At best, they've been kind of sort of working. And the idea of having like a particulate sensor seems cool, but it looks like all we've got is like stuff that you could buy from SparkFun for like under $100. And like tracking for that is cool, but like this is really, I don't know. But did it work for that? Like, did it give you like dust data that you could track in the way that you wanted? Because if it did that, that'd be useful. Even if this is a lot more hardware than you need to actually do that. This glue, okay, I don't think this is glue. I think they just molded the silicone onto this, I think. It's hard to tell, but... I don't think that's the circuit board itself. Oh, that's resin. It's potted. That's resin around the circuit board. And I bet this stuff on this side, that black stuff, is actually probably resin. I hate this thing. Okay, I'm getting the knife. I'm not even in the slightest worried about damaging the soft parts at this point. So I'm just going to try cutting that off. On camera even, so you get to see the carnage. Yeah. A couple people point out that I could get another one. SecTech on the Twitch chat points out that, you can get them cheap on eBay, so you could just get more if they turn out to be useful. And, I mean, there's not necessarily a reason to take it apart just to see what's inside it, given that the schematics are all posted, but it seems like it'll make, good YouTube, plus it might be useful for future reverse engineering. Maybe the pulling was actually working pretty well. I'm also not sure how much I can, squeeze these halves apart, really, without breaking something. This thing is terrible. It looks like I can kind of get in between the layers if I aim the knife just right, and then, I think the strategy that seems to be working here is to kind of fracture the epoxy, right where it's bonded to the silicone. Why would they do this? I guess it's probably waterproof. Maybe that's the only, really good reason I can think of to do this. Oh, did I just crack something? It's quite possible this is very delicate and I'm, flexing it in the wrong ways here. I can't tell if that was, a metal clip or if that's actually, a chip under there. People are, asking me to be more rowdy with this thing. I feel like I'm already... I don't know. I have this weird blend of being... I try to be really delicate with stuff like this because I don't want to break it, but then you've also got to apply a lot of force to it sometimes. So, finding that middle ground is tricky. I think everybody who does this kind of ends up reaching their own peace with it in some way. I'm just, rolling up the rubber on the end of the pliers, which seems to be kind of working. I'm trying not to... If that is a circuit board, I'm trying not to just instantly crack all of the semiconductors on it. Okay, I'm gonna unroll because my pliers are just covered in rubber now. Oh no. Okay, so Allison says that these are washable, which is cool. But James says, the oh no was about James's comment, who says that during the campaign they made it sound like they give you all your data, but after that, nope, not at all. You'd get a few little graphs and charts. Most of the sensors were red, yellow, and green. Yeah, so James wanted an API and numbers that he could play with to get all the data. Yeah, that's disappointing. I mean, seems typical for companies these days, but it could be so much better. Yeah, I've got one IoT thing that I use on a semi-regular basis, and it's a kind of old device, but it still works. It's one of those Wi-Fi way scales. And it's just one of those things that you know, I've like been interested in keeping track of for a long time. I used to do it manually, and now I get more data because I can just like stand on the thing and it saves the data and then sends it every so often. But like I would be much happier with that if it was something where I could have it run entirely just like on a local server. At least with that one, you can export a spreadsheet pretty easily. But yeah, the thing that they're trying to sell isn't really the thing that I want most of the time. Oh, right, yeah, good question about recyclers. Like, how do you open this to get the battery out? I mean, I think I could have just cracked open this side and then the battery might have been more accessible. So I think if I wanted to get the battery out and wasn't concerned about damaging the rest of it, this would have been quicker, to be honest. But I'm trying not to break whatever might be in this narrow part. Which might be a fool's errand, but maybe I'm a fool. Strategically weaken this thing in points. I don't know. I'm probably being too gentle with it. Let's just like make a nick completely through the silicone on. Oh, new card. Let's hope the camera doesn't overheat. This camera's pretty warm right now. But the fisheye lens, I feel like I can almost kind of safely fly this thing just from the camera feed, which is pretty cool. I still need to keep an eye out for obstacles, but soon we'll have a little bit of sensor help for that. But yeah, the fisheye video, I'm pretty happy with it. I think the angle's a little bit too wide right now, but a little closer and it might be just right. Alright, camera, don't overheat on me. Why can I just like, that's right, I have so many cutting tools I could be using. This was definitely molded right onto the thing. Like you can see an exact imprint of like whatever, I can't tell what that thing is there in the middle, but whatever that was, it was leaving an imprint directly on the silicone. Which also explains why this is so stuck and would be great for water resistance. Because yeah, I assume if people are clipping this to their pillowcase all the time, it's going to get thrown in the wash with their bed sheets. Oh, cool. Yeah, Kieran points out that with the Y-thing scales, you can intercept the data by DNS spoofing. Yeah, I don't really expect those things to be secure, but it's also like not something I'm especially worried about. It's like, oh no, somebody's maliciously hiding in my bushes and breaking into my Wi-Fi and stealing my weight every morning. Like, I don't really care, and it doesn't seem likely. It's not like a threat vector I'm worried about, but yeah, I wouldn't trust those folks to make something that I needed to be secure. Okay, well, I'm not quite sure what to do around this like hinge area. I'm gonna try to excavate that a little bit and see what I can safely cut through. Because I need to kind of topologically break this open somehow. I think that might just involve, oh yeah, here's a way in. I can just go in here with side cutters. That's solid silicone. I can just kind of lever that open a little bit and cut it. Yep, didn't cut through any circuitry, just silicone. And there's the flex, which I would have broken if I were to just hulk it open. Yeah, so there's a flex circuit and like a steel band. Sorry, looks like there's a metal thing, right? Like steel band that kind of goes around, which is what provides the tension. So I think I can carefully like bend that band a little bit, but the thing is doing that actually just puts a lot of pressure on this piece. So there's one end of the band. It's covered in Kapton tape, it looks like. And then this is either part of the resin or another piece of plastic that's like a shim. This feels like a separately molded piece of plastic, honestly. You can see the ejector pin even, the little flat area. So this is a separate molded plastic piece that just holds the clip. The clip goes all the way through, and it's going to be behind the circuit board probably. And then there's the battery connected to the flex. Oh, this thing is nuts. Okay, let's keep taking this apart. Although that said, with what Kieran's saying, I think maybe another thing that another way to interpret that is like, oh well, you know, I could intercept the data myself and just have my own local server, which actually it might be worth setting that up at some point. That is the upside of devices with lax security, is that then the vendors themselves can't necessarily retain the control that they'd rather have. I've got some really old iOS devices that I've been meaning to jailbreak just for pretty much that reason, because like Apple doesn't support them anymore. It's not that they're really supported by anybody else, as far as I can tell, very well, but I'm still trying to figure out if any of that ecosystem is worthwhile. Oh, there's a little bit of... Okay, I'm going to take this under the microscope again. Show some of the carnage close up. So, you can see different kinds of resin here. So there's like a clear potting compound of some sort. It's right up next to the flex. And then this is like ABS or something. But then there's the silicone molded around that. All the different kinds of resin have kind of interacted with each other at that boundary too. And the metal op. Okay, let's go back to the overhead. Let's see, maybe the next step is to separate the silicone from that plastic piece on this side. Oh, I can almost get this whole insert out. See that? Now that this back is out, I can start to kind of peel this whole thing back. Like, I don't really need this piece to stay attached. Can I get this clip off, I wonder? It seems like the clip and the clip holders might actually separate from everything else as a unit if I kind of peel this apart a bit more. Like, what if I need... maybe I need to go in this seam? Is that a seam? I don't think that's a seam. it's like I need to figure out where the edge of the circuit board actually is. Yeah, I don't know if the two sides are the same. I might just start going in this edge with the flush cutters. So what's like right under that corner? Oh, this is black plastic that's painted white or something. That's interesting. I was wondering why the color was different on this side, but that black plastic or resin or something might actually be the same material. Oh, geez, is this exterior surface the actual resin potting compound that they then just paint? Is this entire thing just circuit, pot it in resin of a couple different types, and then paint the outside? Ah! Oh, this thing is terrible. I'm gonna try to get the battery off, maybe. So here's the state I've got it in right now. It's got a, what is that, Minergy? Magnesium-ergy? I don't know what that's supposed to be, but a lithium cell of some large flat variety. How does this want to come out? Can I flex the container a little bit to get it out? Oh, that outer ring seems to want to bend. Also, just look at all the layers of, like, this is insulation tape, I think. So there's one layer of insulation tape on this side, another layer of Kapton on that side. This thing is just a mess to assemble, I imagine. And then this is spot welded to the battery, but then how is that actually attached to the flex? I can't quite tell there. Omnigree. Omnigree with that one. Is the battery potted? Can't tell how much of this is just potted in epoxy. Oh, that's a good sign. Okay, so there is potting and a separate plastic shell. I'm like cracking the plastic and then the glue is coming off separately. Oh, there's a circuit board! I've struck circuit board. So, okay, there's some epoxy in it, but most of that black stuff is actually not epoxy. That's just the inside surface of the plastic that's painted white. I think the actual epoxy is kind of more clear colored. And then some of that we're seeing is just the edge of the circuit board. That makes more sense. So I'm just going to peel this back on the edge all around. Is this going to be another flex rigid assembly? I've got to get the rest of this rubber off too. There's only that one small flex, which seems to be battery and... Oh, there's more than battery though. There's a couple of thick traces and 3 thin traces on the right, so there might be some sensing. I don't know what kind of sensors this would have. I assume probably an accelerometer, but I don't know what else. Or why it would need that. Let's definitely take a closer look at that. Oh, that's about to come off in one piece. I still have not disconnected the battery. Everything is still live. So So I'm peeling the plastic off of the circuit board, going around the edges. Oh yeah, good question. Like, what was their answer to the battery replacement? Was it, because like the Tile, which is the like disposable battery, stupid IoT thing that I'm more familiar with because I have a couple here. With those, they intend it to be more like a service where you just like buy more from them. But like you could just put more batteries in. They just make it hard because it's this kind of potted construction. You know, I've never built anything that was like potted and disposable like this, but I had this like pet project. It wasn't my pet project, actually. It was a friend of mine at the time had this pet project that she was trying to get some engineering help with, and it would have been something kind of like this. And so after having more experience with some products like this, I don't think I like it at all. There's not much I like about it. I mean, unless you need it to be waterproof. Okay, it looks like I'm starting to get to the plastic that just holds the clip together, and that's just coming apart too. I'm not sure if I can get, I'm going to try to get just this part off first, just this back part. It seems like the resin is relatively brittle, so if you start flexing it at all, the resin just wants to break. Oh, wow. That is really pretty. It's got a reed switch, I think. Wow, okay, well, I'm gonna, let's take a look at it under the microscope after I get this a little bit more apart, but yeah, that's looking really pretty. Is the reed switch a documented thing? Like, do you hold a magnet up to it to reset it or something? Is that how the pairing works? This is not a QR code, it's a data matrix, but, I mean, usually these are serial numbers, but you're welcome to try scanning it. It's pretty common for product serial numbers, because there just isn't enough space otherwise. Like, they're generally just used to keep track of products during manufacturing, or in the event of a recall, but mostly during manufacturing. Well, like recall or fault analysis, or like anytime you get the thing back, really, is what I meant. But mostly, it's going to be useful for, you know, like as parts pass through the factory through different production steps, you want to keep track of what they are and like what model number and serial number they are and everything. And there's usually a database at the factory for keeping track of the kind of history of production for each unit. Okay, so at this point, it looks like what's going on is there's a molded, so okay, most of this, just for some context, I think these outer pieces, so I was wrong about the thing where the whole thing is just like resin exterior. I think these outer pieces are separately injection molded. I don't know why they're painted white rather than being solid white. That's pretty weird, but I thought they might be like resin. I think it's plastic. I don't know what kind of plastic, but so I think what's going on is that both the outer shells are separately injection molded plastic. These black pieces are separately injection molded plastic, but then there's some kind of resin fill and then this silicone, which is done after it's assembled. That's my current theory, based on what I'm seeing here. And then this is one half of the kind of clip mount. Oh, there's a 3 right there. The other half is clipped onto this circuit board at the edges. So I'm going to try to take that off next. I'm not shy about just breaking off these clips, actually. Trying not to short out the circuit board at all, but the vias on the edge seem to be ground stitching for EMI. Oh yeah, like 2D barcodes in general, there are several different kinds, and they, you know, even before they've been like really popular in the States at least, they've been really useful for kind of internal manufacturing operations. I don't know whether that was the case kind of even before like QR codes in Japan. Like I know that was like kind of on an earlier timeline. Okay, I'm starting to be able to separate these just by pulling now. Okay, so there's one of the clip holder pieces. Here's another clip holder, which I think I can separate from the circuit board. I don't know how thin this circuit board is yet. Okay, here I can see the actual edge of the circuit board. It's not extremely thin. Oh, Tuco found a bit of paper packaging over there on my desk that he's enjoying sitting on. This does seem to be... Is this a different kind of adhesive or the same kind? I can't... Because this is not resin. This is more like soft silicone. But not the opaque silicone that most of the thing's made out of. So I don't know why there's another kind of glue. Maybe this is like some kind of soft conformal coating before they dip it in the silicone. I don't want Tuco eating this. Don't eat any of this, Tuco. I usually have a trash can over here for stuff like this. Or by trash can, I mean bucket. Alright, some of these bits are going into the bucket because I don't want Tuco messing with them. Okay, I'm gonna kind of semi-permanently try to straighten this a bit so that I can get more access. And I want this clip gone next. Oh, here we go. NRF 51422, same chip. It's a good chip. Like, I don't know why they would have used the 24LO1 if they were trying to have flexibility, or, you know, LE1. This is a much better processor, and it can speak both protocols, so, like, if they're in spare no expense mode, then this is certainly the chip they would use. A couple more pieces of plastic I'm just going to throw away. These are injection molded, not especially super high quality finish or whatever, but I'm sure they're fine, just like internal pieces. And then here's the actual like spring seal clip that was inside it. A little piece of foam there for damping of some sort. And some Kapton to keep it from shorting out the battery. Okay, I'm gonna see if I can get the rest of the plastic and glue off, and then we'll take it to the microscope. There's so many details in how this is assembled, though. Like, this was a little spacer that goes, like a little insulating gasket of some sort that goes between the vias there and the edge of the battery. Like, wow. Yeah, this is like some kind of softer adhesive. I don't know what this would be. Something that they put on at an earlier stage in assembly. Maybe to fix the area around the connections in place before testing, before potting. Because I would imagine they would want to do like as much testing as possible before the potting stage and then do a final test afterwards. Because sometimes in the factory you can rework stuff that doesn't quite work. And there's no chance of that really after potting. I don't know if they would bother reworking, but most factories at least want to leave that option open. I remember coming across this product that reminded me of this so James was saying that they felt like way too much effort went into the physical design and not enough into the software. Yeah, a lot of the kind of Silicon Valley and San Francisco products that I'm seeing recently are like that, and it's frustrating. And, you know, a lot of the time it isn't even in the embedded software, it's in the, like, user-facing stuff. It's in the, like, well, what do you actually do with the thing kind of facing software? Like, the actual application is often the problem. Oh! This glue is covering an extremely flimsy, I don't think I broke it yet, but I'm really lucky I didn't. That's a really tiny piece of flex, and the rest of it was glue. I thought the whole thing in the middle was flex, but no, that's mostly glue. That's terrible. Oh, gosh. But I can't tell why it has so many conductors. Maybe it doesn't need all those extra wires. Maybe it's just printed with patterns that they felt like adding that it doesn't actually need. We really need to take a closer look at this under the microscope, and I'm going to try not to break it. I wonder if this is hot glue or anything else that isopropanol would disrupt. That's just one wire. I don't know why it looked like multiple wires, but okay. This glue is annoying. And I don't think it's definitely not hot glue. It's maybe some kind of urethane. I suppose I should measure the voltage on this battery. Oh, that's funny. Allison said that it's odd, this thing where, you know, the user-facing software was worse than the hardware and the internal stuff. That it's odd because she always thinks of that, the user-facing side as being easier. It's funny because I have the opposite impression. I feel like I like doing stuff that interfaces with other programs because they're much more predictable than humans and have simpler needs. So I feel like it's easy to get the human-facing stuff wrong because that stuff is legit really hard. let's measure the voltage. I feel like I'm coming really close to wanting to disconnect these two halves, but like at least now I can do so gracefully with the solder tabs if I wanted. Yeah, battery's full. Let's see if I can get this out. Yeah. I'm feeling better now that I know more about how this is put together, that it isn't just extremely potted, that it actually is like some layers, and the layers mostly want to come apart. I'm still worried about bending the battery. You can pretty much just cut between, like I'm just cutting like the very exterior of this off, and it's a thin layer of plastic and then a thin layer of some kind of glue, possibly multiple kinds of glue. And then the yellow thing is an insulating layer, which I'm like maybe damaging the yellow thing slightly. Yeah, I mean the battery wouldn't have any reasons to be depleted at this point. I made a mess of the yellow insulator, but I don't think I need that especially much. Okay, there is a little bit of flex circuitry stuff on the back. Is that a thermistor? Those are both unpopulated. Yeah. You know, it looks like they designed this flex with space for a sensor or thermistor or something, and then they just cut off that portion. So there's some extra traces that just aren't being used up there. I think that's like some layers of tape and glue kind of stuck to each other. Tape, glue, and epoxy, and solder, and plastic. Okay. That's about as much as we need to disassemble it, probably. Like, this is just kind of glued around the battery flex, really. I don't know if this needs to come off. Maybe it can. We've come this far. Looks like, I mean, the yellow thing was put on before the flex circuit, and then the glue was put on afterwards. So that's, like, the yellow insulator probably just kind of wants to stay there. And if I bend that down a little bit, then that'll stay kind of flat. Okay. It's disassembled. It wasn't that easy. We've got a little bit of time to look at it under the microscope and look at the software. Let's move the cat cam a little. Yeah, this is about as much as I can zoom with the DSLR setup here, but let's switch to the microscope. Let me make sure the microscope is recording. Because I love that high bitrate microscope footage. It's so good and tasty. Yes, it's been recording at 12 megabits, mostly uselessly this entire time. Just the way I like it. I delete so much video. It's great. Oh yeah, that's a good question. Schmools is wondering whether the size of the design was more dictated by the size of the circuit or the size of the battery. Yeah, we can try to find signs. I mean, I'm guessing it was a little bit of each. Let's see, this... I should make sure that this PCB vise is not going to short out my battery. I'm pretty sure this thing is insulating. Oh yeah, that's great. It's like a static dissipative. So this is reading like 50 mega ohms here. But then there's an insulator layer. Yeah. Thanks, Heiko. Just lightly clamp that in. Beautiful laser etched battery markings. That looks soldered, doesn't it? Maybe that is spot welded. I still can't quite tell how that's joined to the flex circuit though. That's a little weird. So, like, I don't know where, if that was a temperature sensor or something, I don't know where that would have attached on the board. Are those test points? Or maybe somewhere that they would have soldered a debug header. Oh, there's debug. Sorry. The obvious one right over there. I don't know what that part would be. I'm guessing an accelerometer, because that's like the other component you need. And then, was that RF over here? Yeah, that via must lead to the antenna, because that's a matching network. You can see the inductor, because it's got the squiggles. Right there. Sorry about the wobble, I've just got to let it settle for a sec. Oh yeah, so yeah, SecTech in Twitch chat was asking. Well, so first they were saying they're pretty impressed at how water resistant this thing would actually be. Yeah, I mean, I think it would actually do pretty well. And then they said the question that they have is if the design cost was too high or if the product failed because of UI design. Yeah, I guess, do you mean like whether it was just like not a usable product, or whether it was too expensive to manufacture, or whether it was too expensive for them to R&D? Like, I can see those all being problems. Like, it doesn't seem like it was cost optimized enough to have been like a kind of reasonable price point consumer product probably in the long term. Like, this probably came out with a lot of like kind of unsustainable funding. But, yeah, I mean, it does sound like the reason that the people, at least who we're talking to here, that had these didn't find them useful was because of the UI, or just, like, lack of software development, really. I'm going to flip this over. What is that green mask? Is that an additional processing step, maybe, to cover up some stuff they weren't using? Like, did they go back to these panels and, like, silk screen an extra layer over it or something? It's so strange. Like, this flex circuit, like, was this... Okay, well, I was like, is this flex circuit some standard product that they customized? No, it has their logo right here. They designed this thing, and then, like, it didn't quite fit their needs, apparently, or they made a last-minute decision. I don't know what's going on here. There we go. So it's got their logo, it's got this design number. And then here's that read switch. I think it's a read switch. So it looks like we've got the power connected across a capacitor. I'm hoping that's a capacitor. But is that actually a read switch? Let's get a little closer. I think that's what this is. Let's get a magnet. Oh, I have stuff on magnets right over here. I don't need to go far. Can't quite tell what that is. Like, I think it's a read switch. Yeah, there's the read. Let's just change the angle, maybe. Yeah, and I will actually get a slightly different magnet so I can hold it closer. What is Tuco doing over there? Yeah, this is a cool place for the camera. Let's give you that view for a sec while I get this reed switch shot lined up. Huh. Can't actually see it actuating. Oh, there it is. Yeah, I'll show you this in a sec. Let's see if I can get closer. Alright. That is a good view, though. Okay, I am going to take this board off of the battery. I'm just going to... Let's do this the clean way and desolder it. I could just cut the flat flex. It's really tempting to cut the flat flex, but let's actually desolder it. I want to line up a better shot of that reed switch, and I don't want the battery in the way, and I don't really want this powered. Let's not hold it that way. That's really good at shorting it out. Maybe I will do the ground first. I need to desolder a little bit. Too much solder. Let's throw some braid at this problem, maybe. Ooh, got some of my favorite braid over here. pretty. That's what I meant to do. Now I should just be able to separate this. Oh, I just touched the thing that was super hot. Let's not do that again. Alright. That part definitely would be a weird sort of hand soldering operation. Maybe not that weird, but... So now we've got a battery with this weird integrated flex assembly thing. And then the actual circuit board. So, some interesting lands here. I wonder, are those... That's not quite regular enough to be like a connector. It does look like those are individual passives. But then another unpopulated microcontroller slot, or something along those lines. And it looks like this is maybe connected to the unpopulated chip. And then that's another 32 kilohertz crystal, it looks like. Oh, well that does look like it's debug for the Nordic chip, though. Oh, you know, maybe there's an unpopulated spot for the other Nordic chip, the one with the 8051. Like, maybe they left themselves an option for a cost reduction path in the future. Maybe that's what that is. I don't know. We could look at the schematic. That's one of the next steps, maybe. So yeah, this is a system on chip with an ARM Cortex-M and a radio that can speak either Bluetooth Low Energy or custom protocols using GFSK modulation. Lots of vias. I don't know why they broke out like all the pins to vias. That's a little weird. There's the antenna, the squiggly thing under the stickers. Let's get a closer shot of that reed switch, and then maybe go to the schematics and PCB, and or just the repository in general should have some interesting stuff. SecTech says that they're thinking that it was too expensive to manufacture. Yeah, I mean, I think that's a given. It was definitely too expensive to manufacture, but I think the question is, like, was that the main reason it failed? Or was it that even for people who, like, either got one through the Kickstarter or were just, like, otherwise willing to pay for one at retail price, whatever that was, that, like, it still just didn't live up to expectations? I don't know. Oh, right, there's a capacitor right there. That's slightly in the way. Can you see it at that angle? I'm sure some of you were like, I've already seen reed switches too much. I don't want to see a reed switch. And I'm like, but they're cool. I want to see them up close. I've actually never looked at one under a microscope. So these are magnet sensors. They're just two metal plates carefully positioned so that they're not quite touching in a glass vial that keeps the positions just so. And then when they're exposed to a magnetic field, the two metal plates attract each other and end up bending just enough till they touch. At least that's the idea. I saw it move. I don't know if you did. There we go. So there's the reflection, which if you ignore the reflection, then you can see maybe a more subtle movement, which I can point out when it happens. So open, closed, closed, open, closed, open, closed. Yeah, open. So it's a little hard to see. This would be better if I was zoomed in more, or if I had the multimeter hooked up to it also. I have some clippy leads. Do I dare hook up the multimeter? I think the voltages it uses for continuity test will be okay in this circuit. I'm sure this is something they would want an easy test point for, so they could test this sensor at many stages of manufacture. Run those cables a little differently so they don't want to fall off. I might just have to hold that point on. Okay, it's a little hard to illustrate because, like, as far as you can tell, I could be just moving the alligator clip. It's kind of hard to see that definitively. I think also my magnet is too strong, and so it's triggering from kind of a distance. Let's put one magnet on the end of a tool of some sort, like maybe this heavy-duty tweezer. It's pretty sensitive to the orientation of the magnet. But yeah, and you can, I mean, I can barely see the leaves moving on my monitor. I don't know if it's visible to you at all, but like, I can see them slightly move, but that's about it. I think it would need a better test setup for it to really be really, you know, interestingly visible. So anyway. SecTech wonders if it would make any sense to hook up a JTAG to the board and pull the firmware. I mean, probably not, because we've got all the source code. I think it'd make more sense to look at the source code. We could JTAG it if we wanted, but I think it'd be more interesting to look at the code. Anyway, I just wanted to get some photography of that. Let me switch the recorder over to the computer screen and we'll head over to GitHub. I'll stash that with the other circuit boards. And done with the microscope recorder, let's have a little bit of computer recorder. train. Go signal. All right. Recording. Ugh. No idea what that is. Vimeo staff picks. Okay, so there's also a through hole. That's fine. I'm kind of done messing with that, but I appreciate it. Oh, yeah, giant alligator clips. Those alligator clips are kind of big. Anyway, let's look at the code, which... okay, it's sold as being fully waterproof. That's interesting. Oh man, see, I get so annoyed when I see these like lists of like, this is just the journalists being complicit in the VC delusions, right? It's like, we don't actually have anything real to share, but here's a bunch of journalists who like it because we sent them a bunch of free stuff, and we're just like friends anyway. It's iconic glow. How is a product that doesn't exist yet iconic? Probably carbonate, huh? So these are the multiple components that make up that cylindrical thing that holds the air quality sensor, the CO2 sensor, particulate sensor, whatever. It's not a CO2 sensor, it's just a particulate sensor. This thing doesn't have a CO2 sensor, does it? It just has a particulate sensor. It has some MEMS-ish stuff that I couldn't identify that might have been something more complicated. It seemed like it had one of those temperature humidity units. So what does this actually say we got? That looks familiar. Yes, yes. Peeps. Yeah, see, this price is not sustainable for the kind of engineering they put into it at all. Like, this is not built like a $99 consumer product. And I mean, I know, because like that's basically the target we were trying to hit for the Siftio cubes, and we didn't really make it as cheap as we wanted it to be. It was still more expensive than we wanted to make it, and it was really, really hard. And with this, it just looks like they weren't really trying. This is like all like VC funded, basically. And this was the original Kickstarter. Like, this just isn't possible. Like, they needed more money than just the Kickstarter to do this. I mean, which isn't like that unusual. I mean, Kickstarter for hardware, like, you're assumed to already have most of your design by that point. But I just don't know how you recoup your investments just through that channel. This is a rendering. Like, and we looked at this video earlier today. This has some real stuff, but that thumbnail looks like a rendering. It's hard to tell, though. Anyway, I think we just want to dive into the source code. So yeah, this is the repository they threw up before completely shutting down. A lot of stuff. Oh my, 117 repositories? Okay, how many useful repositories are there? These people were busy writing code. Like, I mean, how much of this is just cloned other projects? Or maybe they just have... Well, whose ADPCM decoder is this? This one... Have I seen this one before? Yeah, this is IMA ADPCM. Why did they put this in a separate repo? This is like library code they could have gotten a number of places. Maybe this is somebody else's code that they just committed here because it was already a repo. I don't know, man. Research. S3 proxy. There's a lot here. I might just have to download all this with a script. What is this? Is this all their stuff, or is any of this somebody else's? Like, my assumption here is that this is just like all custom stuff. Like, some of this might be existing components, but what was at the end of this list? There's just a lot of custom stuff here. There's a script I remember seeing that maybe I can find. I think it was just like some snippet on Stack Overflow that was a quick way of, with like some shell and Ruby, downloading everything in an organization. This was it. Yep. So this is using the GitHub API to just get anonymously a list of all the all the repos in the Hello organization. And then it's using some Ruby, which is already on OS 10, so it's convenient, to just parse the JSON and shell out to Git to clone each one based on the SSH URL. So yeah, I've used this chunk of code before, and it's quite a handy little GitHub gist. Oh, so James is claiming that the pill board is the one that's interesting at this point. I mean, I wasn't going to jump to that conclusion. Like, I mean, there's a lot here. Like, we just happened to previously in this stream be taking apart that board, but that isn't necessarily the, you know, that isn't any necessarily any more or less interesting than the rest of these. Anyway, I'm going to have to wrap up this stream somewhat shortly because I'm about out of time for today. But we can do a little bit of quick investigation in this collection of many repos before that point. And yeah, let's take a quick look at the pill repo. Why not? What is Morpheus? Is that a hardware code name? Because I'm assuming this is firmware and this is PCB or something. Let's see what's going on here. Yeah, these are Altium files, I think. Yeah, GitHub is not going to serve that. I'll just serve that locally. There's a PDF here, though. And what is Doraemon? Executable file. Hello in the entire box in Altium. Wait, WS2812s? Really? But this is talking about the pill. Or were there WS2812s on their test rig? I'm so confused. Contact spring? This doesn't seem like the same hardware we have. I don't know. I mean, it could be, but contact spring. Because I didn't see any shielding or separate springs. Unless they mean that single piece of spring steel that acts as the clip, but that didn't seem to be electrically connected. That seemed to be insulated. This has a boost for onboard LEDs. I don't think this is the hardware we have. I don't know. Does the pill have an LED on it? Did I miss that? I didn't see an LED, and it didn't seem like they would want to waste the power on an LED. I don't see any LEDs. I think this is not the hardware we currently have. I wonder how many different versions of this they designed. What is BQLE? Combined bottom LED ring. Is Morpheus maybe a rechargeable pill? I didn't see a charger though. Pill.flex. No PDFs? Here's a PDF. Oh, that's the battery flex. I mean, pill identification is a difficult problem. Usually they just have tiny letters on the side or something. Or the bottle tells you what shape and color they are. Oh, history, I see. That could be interesting. Oh yeah, what was BQLE? Bottom LED ring. Oh, this is the bill of materials. Development proto. Read switch. This could be what we have. But it said something about LED rings. QLE is. Energy harvester boost buck regulator. Is that just a really efficient power supply? I assume that there isn't actually an energy harvester. But maybe they were just R&Ding a whole bunch of stuff that didn't actually make it out. Wow. What about this one? Oh no, and this is hardware too. MOPQ. Big ol' fancy Altium Nordic logo. Oh, this is a Nordic antenna part. Or no, an antenna balun at least. So yeah, MPU 6500 is the motion chip. Yeah, this looks like what we have. It has a little bit of flash. Antenna, spot for the flex. Stitching vias. Cool. So what's that little chip? Oh, is that flash that was unpopulated? That's U4. Whoa. Are you a breakout? Huh. What is going on here? Did they just use this to fabricate a breakout board too? That's really weird. Okay. So yeah, I just downloaded 3.3 gigabytes of code from their GitHubs, or like code and schematics and everything else. Oh gosh. Oh, the user's guide has its own repo. Oh, star, not dot. Oh, they have their own copy of GCC in here. Doraemon is like the biggest repo other than that. Did they just check in? They did. They just checked in the binaries for GCC in a GitHub repo. That's cool. Nice job. Doraemon, poke.bat. Yes, poke.code into the mon. So this is their automated testing and build? Or is this just the firmware repo? Maybe this repo is build because maybe this repo is big because it includes a bunch of binaries. I don't think this has code. Korea. There's so much stuff in here. And I've got to go soon, but if you have ideas for what you'd like to see me do with this project next, I'd love to hear them, as always. It seems like a lot we could do. This is such a sprawling code base for something so weird. So like in some ways I just like really applaud them for releasing all this, but I personally probably wouldn't have wanted to release just like such a big unstructured dump of everything, because Like I don't know, it's just like hard to know what's in there. Sometimes you might accidentally release like somebody's personal information or something that you don't actually have rights to. So like even like when I worked at a startup and then later the startup went bust and we open sourced everything, like that was a project that involved a bunch of work just to make sure everything was both what we wanted to release but was also like actually possible to build and was potentially useful. And that's like maybe not the minimum bar, but it's like what I would prefer to do. There's like a pill utility written in Go. Yeah, see, it's like, you know, it's like, oh, we've got S3 buckets in here. Probably don't have any S3 credentials, but who knows? When we released code at Siftio, we were very intentionally releasing the encryption keys. Like, that was certainly not an oversight. Like, stuff like that makes a lot of sense. But, like, because, like, the keys to encrypt firmware, it's like, well, that's part of what you want to give away, right? But, like, the keys to, like, infrastructure you were renting, for example, that's maybe not what you want to give away. I mean, that stuff should be revoked anyway, but, you know. Sense BLE tester. That's cool. What's the BLE protocol like? So are these BLE commands that we're sending to the base device, like not the pill, but the sense itself? I guess that must be, because sense is the actual base station device. Interesting. So how is this stuff authenticated? So we have a self.sense manager. Is that what sense kit is? This seems Apple-y, but this is in Swift. Where's the actual code in this package? Pod. Okay, classes. Pill manager. Oh, this seems useful. Yeah, so this is going to be communicating over GATT, which is the basic like, Bluetooth Low Energy kind of database, kind of key value sort of encapsulation that everything has to use. So generally, like everybody who designs a BLE protocol kind of makes a decision about how much to split up the problem into kind of different BLE resources, like different GATT attributes, versus how much to like do their own packet structure. I'm kind of curious where they ended up here. Just using set Wi-Fi as an example of something that would be sent over the network, or over the BLE. So this builder is a packet builder of some kind. Where are we instantiating that? Oh, here it is. Message builder, yeah. Is there any authentication? It's probably just using BLE pairing. Yeah. Is the message builder in a different... Oh, protobufs. Oh. Cool. Okay, so the message builder is generated code from the protobuf library. Well, this is handy. I mean, this is like a Bluetooth controlled alarm clock and Wi-Fi scanner and LED trippy. Sure. Alright, well, I should wrap this up. I gotta get ready for my next thing. But, yeah, this was really interesting. I think we did like a decent kind of cursory teardown. I'll work on turning this into an edited video. And do let me know what you think we could do next. There's a lot of options here, and between like kind of putting it back together and trying to actually use it as a sensor of some sort versus doing various kinds of firmware modifications, versus just like digging through this code and see, like, this is a great example of just like the aftermath of a huge amount of product development work, right? Like huge amounts of effort were poured into this to reach this one particular slightly strange goal, and it's kind of interesting to sift through the debris after that. So, oh yeah, I was noticing the thing that said on the Git repo that we liked to build things in the past tense. Yeah, that was a little sad, right? It's like, no, we just don't like building things anymore. Everything is terrible. Everything sucks. We're all depressed now. Yeah. Yeah, I hope they're doing alright things now. But I don't know, like, I have mixed feelings about it, right? Because, like, on the one hand, like, I've been there. I've been just, like, building something kind of ridiculous using a lot of, like, you know, just, like, optimism to kind of fuel the whole thing. Like, optimism and venture capitalism. And so, yeah, it's like a weird process, and I have some nostalgia for it in this weird, twisted way, but I don't at all think it's a good idea or something that's worth celebrating. So it's like, but it's also something that leaves all these interesting artifacts. So it's almost like being an archaeologist, like sifting through the debris of a ruined civilization or a burned city or something. It's like, well, yes, this was a tragedy. This shouldn't have happened, but it's full of all these interesting clues about just how humans and technology work. So it is kind of interesting to me, even if it's kind of weird and kind of sad. Anyway, yeah, I gotta wrap this up, but thanks so much for joining me, and thanks so much for sending this in to Allison. This is a really interesting device to take apart, and hopefully we can give it some kind of second life here on the internet. So yeah, thanks a lot. I'll see you all later.